This is a demo to walk you through the capabilities of Azure Machine Learning Python SDK in training a model and deploying it. Azure provides two ways of achieving this. One is using the automated machine learning to generate a model that best fits the dataset, while the other is the hyperdrive for tuning a model's parameters to optimize its performance. So we begin off with the automated ML because the automated ML gives you the clue as to which of the model you can tune to optimize its performance. So we've imported all the necessary dependencies and then initialized the workspace, then created an experiment which we call the liver disease AUTOML. Then we can either compute a cluster or use an existing cluster. Then the data set of interest is the liver disease data set. Or the goal of this classifier is to predict whether a subject is healthy or not healthy. We load the data store and some functionalities to clean the data set because there are categorical data available. So once we've been able to do that, then we set up the AutoML configuration. And from the AutoML configuration run, we're able to see that the voting ensemble gave the highest accuracy, which is 99.97 or 98%. Okay, approximately 98%. We have here at the 5th position is the SG Boost classifier. So now we are going to go over to the hyperdrive run. The same thing, we import all the necessary dependencies and we are using the same data set. We color our workspace and then create an experiment, use an existing cluster. Then we have to set up our environment folders. That's where our training file will be for running this experiment. Then we set up the hyperdrive configuration. So for our hyperdrive, we chose 3 key parameters to achieve performance or optimize the SG Boost classifier performance. They are the N estimators, the maximum depth, the subsample. So the N estimators is the number of 3s, while the maximum depth is the depth of the 3, and then the subsample is randomly selected subsets of the training dataset. Now, these are known from literature to be key parameters that can optimize SG Boost classifier. So, for our hyperdrive sampling, we chose the random parameter sampling algorithm to be able to sample the different values of these parameters in order to find the best optimize the parameters. And from the runs of this hyperdrive, we were able to see that this hyperdrive run actually outperformed the AutoML, okay, because the accuracy is 99.987, of which if we approximate this is going to be 99.99%. So the hyperdrive was extracted here from these details, having a maximum depth of 5, N estimators as number of 3 is 1000, and then the randomly selected subset of the entire data set, training data set, is 0.8. So these are the parameters from the best run, and the best run ID is given as this. So we'll go ahead to deploy this model because it's the best performing model. For our deployments, we need to set up the environment and the variables. So there are necessary libraries that needs to be imported for us to have the successful API call to the model. They are the NumPy, the sklearn, the pandas, and Azure ML SDK, and then the SG Boost model, deployed model. So for our deployment, we are using a web service on Azure Container Instance. And as you can see that the status of this web service is the deployment has succeeded and it has a healthy status. And so we'll go ahead to a JSON request or call to the model that has been deployed. And from our prediction, we're able to see that the first patient actually has a liver disease, while the second patient doesn't have the presence of liver disease. So if we go over here to the Azure Machine Learning Studio, we will be able to see our deployed model with the deployment name, which is the M service. So when we click there, we'll also notice that the status of the deployment is also healthy. And then we were able to activate, or rather enable, the application insights to give us the status of the application during runs. Thank you.